First question that you guys wanted me to go over was get dog breeder. So we do const get dog breeder is going to equal a function. Okay? So now, what we want to do is we want to return another function. And that function is going to be called dog breeder. Okay? No. So I'll make the block, and then at the end, I'm going to return dog breeder. Okay? Since I'm using the function keyword, I could have done this here, but I'm not going to do it. Okay? So basically, you guys wrote a function before in a previous workshop called dog breeder, I think.
Yes.
Yes. So you could have used code from there if you wanted to, cut corners. But if you didn't want to do that, you would have to write this function again. So this function, again, would take a name, and it would also take an age. And then inside of here, we had to remember, like, dog breeder can take either a name or an age or just an age or nothing, okay? If those things were nothing, then we would fall back to default names, okay? So we can start right away. If type of name is triple equal to number, because we know that if we're only passing in an age, that means that number will be captured by the name parameter. Does that make sense to everybody? Since it's going to be captured by the name parameter, we don't want to reference that number as name throughout our code. We want to reference that as age. So we just say if type of name is triple equal number, then we'll say age is going to be that number. We will reassign age to that number because we know that the user running our function meant that number to be age. Okay?
I said, like, if age is undefined, age equals number? Like, if someone didn't put in a second.
We'll get there. We'll get there. So we're just gonna tackle the passing in a number only first. Okay? So then we could say name is going to be equal to what? Right? Where does the default name come from? The default name should come from here. Okay? So the default name is actually going to be passed into the higher order function. Okay? And the default age. So then we could just say, whoops, default name. Does this make sense for everyone? Yeah.
What is age equal number?
Oh, my bad. Wait, age equal name. Haha. Okay. Does that make sense to everybody? Oh, now, before it made no sense. My bad. All right. So, and then to tackle this problem, what if nobody passes in anything, or what if someone just passes in a name, right? So we could just say name equals default name here, and then age equals default age here. Because of ES6, right? We can set these parameters to have a default value in case the user doesn't pass anything in. Because those default parameters, those default name and default age, those things will be defined when they run get dog breeder in the first place, okay? So then, after here, we could say let new dog is going to be equal to name age. This is also shorthand. If I'm making an object, name, colon, with the exact same thing, name, colon, name, you can omit that and just write name. Whoa. Okay? Is it hot in here? Do you want me to turn the AC on? Oh, my bad. It's just me, huh? Okay. Ooh. Anyway, so, and then we return that new dog, right? And there we have it. Any questions on this?
You said we were going to go over that.
What was your question? This is the question. This handles that.
That handles it.
This is the same thing as saying if name is equal to undefined. It's the same thing. Because if name is equal to undefined, that means name wasn't passed in, right?
Right.
So if name isn't passed in, then setting it equal to default name up here in the function definition handles that case. So you don't have to write like two if statements inside of your function that for something that can be handled right here. Does that make sense?
Yep.
Cool. Yeah.
Line 11, does that comma have to be there?
Yeah. So this is the same thing as writing name, name, age, age, right? So key in an object, key value pairs, to separate them, you need a comma, right? This is one key value pair, this is the other key value pair. However, since age is the key, and it's going to be equal to a variable that's called age, we actually don't need to do this. We could just do age. And this is shorthand. JavaScript will just take care of that for us. So this looks like array syntax, right? Like this element and that element. However, it's really name, colon name. I'll put this in quotes. Oh, what the hell? Okay.
I have a dumb question.
So,
What's running in the background to let it like say, okay, you just wrote name comma.
oh, I don't know.
Make it. Okay.
No, I don't know. Let me just refresh the page because there was a weird error down here. Okay, cool. Any other questions on Get Dog Breeder before I do cache savings? Not bad, right? How does everyone feel about higher order functions? A little confusing at first, but then it kind of makes sense when you think about it a little hard, right? Cool. So now let me do cache savings. So if I do const cache savings, right? And this is going to take a callback, okay? And callbacks is jargon for a function that we pass into another function. The function we are passing into that function is called the callback, right? So callback is going to be a function. Sometimes I like to write func to know that it's a function, but callback is preferred, okay? But like you can do whatever you want. I don't care. So we say cache is going to be equal to an object, right? So this problem was just tricky, in my opinion, to figure out, like how to do this, right? So when we think about it, we are writing, like we're designing something that should recognize arguments. Like we have this one function over here, and this function is going to be called a lot, okay? It's going to be called like 1,000,000 times. But it kind of takes a long time to run. So if we called it with a before, and we know what the result is going to be, we want to just not call the function because it takes long to run if we know the result. So if we knew we ran it with a and that equaled b, if somebody calls it again with a, don't run this function, just return b. So that a-b relationship needs to be stored somewhere else. And that a-b relationship is the cache. And a-b, a colon b, a-b key value pair, you should be thinking objects, okay? So we have this object here, and I'll call it cache, right? Then, the tricky part was to say we're returning a function, right? And that function will take an argument. You can write it like this. You could write it like this, whatever, okay? So we return this anonymous function that's going to take an argument, okay? Then we say if arg is not inside cache. So if this argument is not in the cache, if this is a brand new argument that we're going to be calling our function with, then we say cache at arg is now going to be equal to that callback invoked with that arg. So this will return the result, right? And that result will be the value, and the key will be the argument, right? So we want to call that and put it in the cache. But no matter what, even if this isn't true, if this isn't true, that means it is in there, right? So then after we make that check, if we ran this or we didn't, we still want to return cache at arg. And it's that simple. It's definitely tricky to think about, okay? So when we call cache savings originally and set it equal to something, that's setting it equal to this function, but this cache is stored in memory somewhere, okay? So that means every time we call this function, we pass this callback. Every time we call this function then, we check to see if the argument is inside of this cache, and if it's not, then we call the callback. Because this has reference to the callback that this was originally called with, okay? We call that callback, take the result, and put it in the cache, okay? Then we return cache at that argument. We return that thing that we just put there. If we didn't run this, if it was already in there, then we don't run callback. This part is skipped, and we go to the next line. And then we just return what is in our cache already. Tricky, right? Any questions on cache savings? How do you guys like this room? Nah? It's worse?
Little frame.
This is the room I was in when I learned. This room. My blood, sweat, and tears are on that floor over there. Yeah. Anyways, so that's cache savings. So let's get into recursion, okay? So there's actually a lot of things you're going to learn today. However, I just want to be real with you. Tomorrow, I'm here again, and it's the last time you'll ever see me. So tomorrow is recursion 2. However, we won't be learning new things about recursion tomorrow, okay? Everything about recursion you'll learn today. Tomorrow we'll just be using recursion in a more complex situation, okay? So everything about recursion you're going to get off your chest today. So what is recursion, right? Recursion is when a function calls itself. And it's that simple, okay? But before I get into functions calling themselves, we have to talk a little bit about JavaScript in general, okay? And we have to talk about how it's single-threaded, how the language is single-threaded and what that actually means, okay? So JavaScript is a single-threaded language, so that means that it can only run one function at a time, okay? Let me show you an example. So we have function say hello, right? And that's just going to console.log hello. And then we have function say goodbye. And this is just going to console.log goodbye. Okay? So then at the bottom, we will do say hello. And then we will do say goodbye, right? So if I run this page, we get hello and goodbye, right? So what happened was this line ran, then this function ran, and then when this was done running, then we could go to 46, right? This shouldn't be new to anybody, right? Does this help with the lights? Do you want me to turn them? I didn't ask you guys first. Do you want me to turn them back on? No? Okay. So how about, what if I did this though? What if I didn't call say hello here and I called it here inside of say goodbye? So obviously the same thing happens. However, what is really happening behind the scenes is vastly different. Because we're running say goodbye, but as we are running a function, we call another function, okay? And since JavaScript is single-threaded and can only run one function at a time, how does it keep track of what function we should be running at what point of time? And this is when I want to introduce something called the call stack, okay? The call stack is how JavaScript knows which function to run at what point in time. And the call stack is literally a stack, right? So I'll imitate it down here with commas. So as JavaScript runs through this page, we have the function say hello, function say goodbye, right? Two function definition. Nothing happens yet. Then we go down and we hit line 46. Say goodbye is invoked, okay? This function is invoked. So that means we do say goodbye. That is thrown onto the call stack, right? So now we have to run this function. We have to see what happens. So we run say goodbye, and the first thing that happens to say goodbye is say hello runs. So JavaScript says, okay, another function is running. I'm going to throw that on the call stack. And while this is on top of the call stack here, say goodbye is actually paused. Say goodbye is not running right now, okay? Now we are running say hello, okay? Does this make sense? I feel like this isn't really too complex to understand at first, right? Like we run say goodbye, we put say goodbye in the call stack. Easy. But then inside of say goodbye, we are running say hello. So that means say goodbye is actually paused and say hello goes on the call stack. Because JavaScript runs the function that is at the top of our stack. So now since say hello is at the top of our stack, we run say hello and we get hello in the console, okay? Then when we hit line 38, we console log it, and then that function is done running. So then we take it off of the call stack. And this can finish running. So now that this finished running, we finally hit line 43 in this function. And because this is the last thing on the call stack, so we finish running say goodbye. So that's why we see console.log goodbye then. That is visually what is going on, okay? Any questions on the call stack? Cool. Okay. So, let me see something. 1 second.
I have a question.
What is your question?
If you put line 43 instead of line 32,
If I put line 43, what?
just switch line 43 with line
Like this?
42. Yeah. So that means it will call that.
So goodbye.
Then it will say hello.
Yeah, goodbye would run first because that is the order of the function, right? We console.log goodbye and then say hello runs. Just because that there's nothing after here doesn't mean that say goodbye is not paused though. Say goodbye is still paused while say hello is running. Like, because JavaScript hits line 43, it hasn't read the rest of that function yet, okay? So say goodbye is technically still paused even though there's nothing left. You know what I mean? But yeah, this will change it. Let me just see. Okay. So I'm going to run through. Now that we know what that is, now that we know what the call stack is, now we can finally figure out how we do recursion, right? Keep the call stack in the back of your mind, okay? So let's say I wanted to write a function that counts down from 5 and logs out 5, 4, 3, 2, 1, and then done. Okay? Let's say I wanted to do that. So obviously, I would say function, nope, const countdown is going to be equal to, well, we'll pass it a num, and we'll count down to whatever that number is, honestly. So, because that makes more sense, right? We'll let you guys decide what we count down to. So now, I can just say, for let I equal num, I is greater than 0, and then I plus plus, minus minus, right? And then here, we can do console.log I. And then after this, we could console.log done, right? So if we run this with 3, we would get 3, 2, 1 done. Oh, let me comment this out. We would get 3, 2, 1 done, right? Does everyone agree with me? Cool. So, how can I use this? How can I change this so that we use recursion instead? How can I make this loop go away and instead call countdown itself again to get the same result? So, the first thing that you should do when you're tackling a recursive problem is to determine when you need to stop. Because just like there are infinite loops with while loops and for loops, there can also be an infinite loop of recursion. Because if I just did this, countdown num minus 1, this will say maximum call stack exceed. Because what am I doing, right? I say countdown 3, I pass in 3, and then I call countdown again with 2, right? 3 minus 1 is 2. And then I call countdown again with 2 minus 1, so that's 1, right? And then I do 0, then I do negative 1, then negative 2, then you know what I mean? So the call stack, that's what this means, right? Maximum call stack size exceeded. There's a literal call stack that JavaScript uses, and the size has exceeded because we've reached an infinite loop. So, just like while loops, how you have to make sure you increment your counter at the end of the loop or wherever you want in your loop, I don't know what you're doing, we need to figure out when we can return, when we can stop our function, or when we can just stop calling the function again, right? So that is called a base case. So if num is equal to 0, we can console.log done. Okay? Else, we console.log the number, and then we call countdown of num minus 1. Okay? And then we get 3, 2, 1 done again. Who's confused? Who's confused at what's going on? I know all of you are confused. You don't have to say anything. What's up?
I know like in the command line you can do like Control C and then it'll kill the infinite loop or
Yeah.
whatever. Is there a shortcut way to do that with Replit or with
No, you just have to stop it. But usually you saw a REPL, it broke.
Yeah.
Yeah, so REPL kind of has backup things can recognize infinite loops and just kill the program itself.
Cool. Okay.
Yeah. So, but yeah, you use Control C. Yeah.
So you're each time checking first that it's not equal to 0.
Yes. So this is kind of a rule of thumb, best practice with recursion, right? Figure out your base case, because if this, the if statement will run, and then the else statement won't run, right? So in our if, we're not calling the function again. We're just console.logging done, and we skip the else, and then the function's over. Okay? Let me show you what's happening through visualization with the call stack. because that will make this a lot clearer. I promise, okay? So let's say we have countdown of 3, right? Call stack. Let me slow down a bit. Okay. So we call countdown of 3, right? So immediately we put countdown of 3 onto our call stack, right? So we are running countdown of 3. We are running this function. Num is equal to 3. Is num equal to 0? No. If num is equal to 0, else, now what do? We console.log num. That's why you see this 3 here. Then we call countdown of 3 minus 1. So that means we have countdown of 2. Do you guys agree with me? And what happens when countdown of 2 is on our call stack? This is paused. Countdown of 3, our original function, is paused. It's not running anymore, okay? Well, it will finish eventually. But now, countdown of 2 is put onto our stack, so we have to run that before we can finish running 3. Does everyone agree? Agree?
Agreed.
Agree? So, num is 2. Is 2 0? No. We go into the else, console.log num. Num is 2. We get our 2. Then, we say countdown of num minus 1. Countdown of 2 minus 1. So now, we are calling another function. We're invoking another function, right? So we do countdown of 2 minus 1, so of 1. And that goes on the call stack, and now this is paused as well. Okay? Because JavaScript is single-threaded and can run one function at a time. So this was running, countdown of 2 was running. However, now that we got countdown of 1, we have to run that first and see what's going on. So num, is that equal to 0? No. Else, console.log num, that's why we see this 1 here. And then we call countdown of num minus 1. Countdown of 0. So this is paused. And then we do countdown of 0. Now we are running countdown of 0. Is 0 equal to 0? Yeah. Yes, it is. Yes, it is. Yes, it is. So countdown of 0. Anyway, console.log, done. So this will actually give us done in the console. Okay? So now that we hit this if statement, our base case, do we go into our else? No, right? We don't do that. So we skip over this and finish the function. So this function is now done running. And what do functions do when we don't tell it to return something? It returns undefined, right? Not that it matters for this function, but it will for other functions. It returns undefined. So since it's returned something, that means countdown of 0 is done running. Does everyone agree? So that means we take it off of the call stack. Now, we were here. We were paused here before, right? We were waiting for countdown of 1 to finish running. Countdown of 1, I mean, we were inside of countdown of 1. We were waiting for countdown of 0 to finish running. And it just returned undefined, right? Like now, since countdown of 0 returned undefined, that's what we were running on the call stack, it's gone. So this was running countdown of 0 before. So now we can finish. We can finish countdown of 1. It didn't return anything. This returned undefined. And countdown of 1, as we finish this function, returns nothing as well. So that also returns undefined. And since this returns undefined, it gets taken off the call stack. Now we can finally finish countdown of 2. The whole time countdown of 2 was waiting for countdown of 1 to finish running. Countdown of 1 just returned undefined. I just showed you, right? Since that returned undefined, we can config whatever, it doesn't matter. We got our console log. And then we finish that function, countdown of 2. And this also returns undefined. Okay? Since that returned undefined, it's not running anymore. So, countdown of 3, which was waiting at this point on line 57 this entire time, the first thing that we did over here, we were waiting for countdown of 2. Countdown of 2 just returned nothing, so countdown of 3 can finally continue, and this can return nothing as well. Right? And then we could take it off. And our stuff was already in the console. Did that make more sense? A little bit?
I'm a little confused about you saying it returns undefined because, like, why doesn't it return? Like, why doesn't it literally return undefined?
Well, if I said like
Return it.
const what am I is equal to this, and then I console.log what is this? What am I? Right? Then I would get what did I do? Oh yeah. Then I would get undefined. Right? So like this function didn't care about any kind of return value. But functions still return something, right? They always return one thing. In this case it's undefined because I don't tell it to return anything.
So even though it's console logging.
Hmm?
So even though it's console logging a number.
Yeah, I mean, like, if this wasn't a recursive problem, and back to the loop that I did before, that would be undefined as well.
Right.
Yeah.
Is there any difference in speed between like doing the other kind of loop and this?
So recursion can actually take up a lot of memory, and it can be slower. So why do we use this? Right? This is just confusing for no reason. Sometimes it's not, though. Sometimes it's actually easier to solve questions recursively. I can't really explain that to you right now, but I can't give you an example. However, it is easier, okay? Sometimes. Also, let's say, I think, like, you guys did some problems where you had multi-dimensional arrays and multi-dimensional objects, right?
Yeah.
And you knew, like, if this thing's an array, then loop through that, right? What if you didn't know the depth? What if you didn't know, right? What if you had to check like 25 levels down, but you had no idea how many levels that was? You can recursively go into it until you hit something that isn't an array, right? Versus writing loops. Okay, well, if this is where I could write doing that 25 times, but you never know if that will be enough, right? Whereas recursion will go on and on and on until you hit your base case. That we will talk about tomorrow, using recursion inside of arrays and objects, okay? Right now, we're just talking about this, okay? Yeah.
So the difference between this and a while loop? Because
Huh? What do you mean?
with the while loop as well, you would know, like, as long as it's, while it's bigger than 0. Well, it's not equal to 0.
Well, yeah, I get it. But, like, I'm talking about, like, diving deep into, like, arrays and stuff.
Okay.
It'd be more, I don't know. It would just, in my opinion, it's easier to, like, reason about with recursion. I don't know. Any questions on this? Oh, shit. Any questions? You guys are good? Like, come on, guys.
Are you gonna do something where it does return something?
Yeah, I will do that. Yeah, I will do that. I thought maybe I would just show, because, like, I feel like, do you guys remember when I said, oh, the slides help a lot because I had diagrams? I have diagrams this time, too. So I don't know if, like, you'd rather me do it over here or on the slide. Whatever. I'll do it on here. I'll show you guys. Okay? Okay. Let me see. What should I do? So, do you guys know do you guys know what factorials are? Cool. If you don't, that is fine, okay? So a factorial is essentially like what could be represented like 2 like that, 3 like 3 bang, 4 bang. So what does this actually mean, right? So this is going to be equal to 2 times 1. Oh, whoops. This is going to be equal to 3 times 2 times 1. And this is going to be equal to 4 times 3 times 2 times 1. Okay? And so on and so forth. This is what a factorial is, okay? So what if I told you I wanted to write a function, given a number, returns its factorial? So like 3 factorial is 6. 4 factorial is 24. Okay? So now we have to figure out how to do this with recursion, returning values. Okay? So how do we even start this, right? What was the first thing I told you guys to do? Yes, a base case, right? So the first thing that you guys really need to do is you need to determine when your function should stop calling itself, okay? Once you figure that out, then everything else becomes actually a little easier. Sometimes it's really hard to determine what your base case will be, okay? So usually the base case should be the type of thing that you are returning from your function. So I'm returning a factorial, I'm returning a number, right? So our base case will be a number. But what would that be? I didn't show you, my bad. Factorial of 1 is equal to 1. And factorial of 0 is also 1? Oh, okay. Some people know. Cool. So if these two things are definitely 1, right? Then we know that if num is equal to 1 or 0, we can return 1. Because anything times 1 is itself, right? So if we return 1, then we could kind of backtrack up. You'll see. So if we say if num is triple equals to 0, or num is triple equals to 1, we can return 1. And this is our base case. Then we need to sort of concatenate these numbers. We need to multiply the result numbers together, throw them back up to the original call, and return that, okay? So what if I just did return num times factorial of num minus 1? This is step 2, okay? Step 2 is during your recursive call, make sure you are changing your input in a way that will make your base case hit eventually, right? So I'm throwing in num minus 1 because our base case is 0 or 1, right? So this will be down every time until we return 1. Then we can just return this minus that. So if I say let results equal factorial of 3, and I console.log result, I get 6. If I do 4, I get 24. If I do 5, I get 120. And if I do 99, I get a big number. Okay? So let's focus on 3. What am I doing? What am I doing, right? Why did I do it like this? why am I returning this 1 and then multiplying it with the current num? What am I doing, right? This is easy to understand if, I swear to God, if you visualize the call stack every time, okay? And this will become easier for you so you don't have to do this stupid thing down here. Call stack is going to be this, right? This will get easier over time, but like this will really help you out in the beginning if you visualize your call stack when you're doing recursion, okay? So let's think about it, right? When I call factorial of 3, well, okay. I'm setting result equal to factorial of 3, right? So factorial of 3 actually needs to return something. But before we set a value to the result variable, we have to figure out what factorial of 3 returns. So we put that on the call stack, and now we're running it, right? Num is equal to 3. If num is equal to 0 or 1, it's not. So we skip this statement, okay? So now we are going to return num, which is 3. So this returns 3 times factorial of 2. 2, right?
Yeah, but that's
3 minus
that's what
1.
it is, too.
Num minus 1. Factorial of num minus 1. 3 minus 1, 2. So does everyone agree that factorial of 3 returns 3 times factorial of 2? Does everyone agree with me there? Right? This. Okay? So now that that's the fact, now that this is returning this number times another function call, JavaScript's like, what are you doing? We have to run this function. I don't know what I'm multiplying 3 with. I don't know what that is. So I have to figure out what that is. I have to run factorial of 2. So now this is paused. Right? And then what do we put on the call stack? But factorial of 2. And this is going to be equal to what happens? Factorial of 2, we run it, num, let me put this down a little bit. Num is 2 equal to 0 or 1. It's not. So we skip this if statement and we hit a return statement, right? We return num, that 2, and it's going to be times factorial of 2 minus 1. So, of 1. Correct? Now, JavaScript's like, what are you trying to multiply 2 with? Because the whole time factorial 3 is paused. Because we are now have to run another function. So now this actually gets paused as well. Okay? And what do we put on the call stack now? Factorial of 1. So now we run factorial, and now num is 1. And now, as you can see, we have hit our base case. And if we return on line 75, if we are in here and we hit line 75, will anything else in that function ever run? No, because the return keyword stops the function. So num is now equal to 1. So we return 1. This returns 1. So this is now taken off of the call stack, and factorial of 1 returns 1, right? So 2 times 1, factorial of 2 can finally finish running. 2 times 2 is 2. This isn't paused anymore. So factorial of 2 returns 2, right? I just proved that to you. So now factorial of 2 returns 2. Then factorial of 3, we were waiting this whole time. Originally, factorial of 3 returned 3 times factorial of 2. Factorial of 2, when we just ran through it, returns 2. So, factorial of 3 returns 3 times 2. So this returns 6. And that was taken off before. So factorial of 3 You get 6. You can think of it as visually, we are at the top, right? We're at the top with 3 as our number, right? And we're like, okay, we have to figure out where we want to stop the recursive call. So we figure that out like 0, 1, 1, because factorial of 0, 1 is 1, right? So that's like the lowest thing. And 1 multiplied by whatever is the same number, right? So we go down and down and down and down. We take that 1, throw that 1 up to the next level, multiply it with the 2. Take that 2, throw it up to the next level, multiply it with that 3, and we get 6. Then we take that 6 and we throw it back up, right? It's like a stepping thing, going down,
It's
okay?
like Inception.
It's kind of like Inception, a little bit. Does this make sense? Does the call stack help you understand more? A little bit more? It's important to visualize this, okay? It really is, because this is, you will trip yourself up 100% if you try to do all of it like in your head, okay? If you're not comfortable, okay? If you're not comfortable, write it down on a sheet of paper with a pencil, even. You don't have to type it out. Don't lose track of where you are. Also, another tidbit that I would like to recommend is when you're tackling a problem recursively, before you just run your function and then you're like, damn, how can I debug this entire thing? Try on the side to run your function with the minimum most thing, the minimum most input. Like, try to figure out what's going on. If this didn't work for some reason, and I was trying to figure out like the factorial of like 12, right? That's gonna be a lot of iterations. So the first thing that I would want to do is figure out if factorial of 2 works, because that's a maximum of 2 iterations, right? So start with small inputs where you expect simple outputs. Okay? That's a good place to start if you get stuck, if you have to debug something. Okay? Any questions? Okay.
It seems to be short when using the while condition.
Shorter? What do you mean shorter?
While num greater than 1 returns num times factorial, num minus 1. And on the bottom, return 1.
Well, this is 2 lines too, right? Like this is 2 lines.
Greater. Oh, I see. So you can say if num is greater than 1.
Yeah, you could do that too. Like if num is less than or equal to 1, right? Then you return 1. But like, that's
Or less than 2.
yeah, I guess you could even like stop this at 2, honestly, and return 2 at the end. But whatever. Right? So recursion kind of gets more useful when you deal with like actual data structures, okay? Like trees and graphs and things like that, which you will not cover in this course and you will learn about at the end of full stack, okay? So don't worry about it. But like, it really does help, okay? You're just gonna have to trust me on this. Okay? Plus, the admissions test will probably be in recursion, so you kind of got to know it. Because if you don't, Okay? So now, let's talk more about this in slides, okay? Oh, jeez. Okay? These slides are good, okay? I customized them. So anyways, so definition of recursion, we'll talk about that. We'll talk about the call stack again, just to go over what I did, because I kind of went over it a little fast. And then we will do the countdown example again. We'll do the factorial example again. Then I'll briefly talk about recursion with strings and arrays. Okay? Tips for approaching recursion problems at the end. So recursion occurs when a function calls itself, okay? Recursion is an alternative to iteration using a loop. anything that can be solved looping can be solved recursively as well, and vice versa. So in the real world, you may see recursion instead of iteration when a recursive solution is easier to reason about. So recursion actually does help break big problems into smaller chunks, and it's easier to read than an iterative solution sometimes. And however, it does affect memory sometimes, but it won't affect performance that much. Okay. So, and like machine learning, AI, traversing data structures, these are where recursion flourishes. Okay. Don't ask me how in machine learning or how in AI, because I don't work in that field, so I don't know. Okay. So JavaScript is single-threaded, right? So that means that it can only run one function at a time. That's what single-threaded means, okay? So the call stack is the structure JavaScript uses to figure out what function it should be running at any point in time, okay? So whenever we call a function, like I showed you this before, function first gets called, it gets thrown on the call stack. And then we see I am first. Then first gets taken off of the call stack. Does this make sense? Because then second goes on the call stack, and second runs, and we see I am second. And then second gets taken off of the call stack. Okay? Does this make sense? Call stack is okay with you guys? Cool. So, write a function that counts to 1, right? So this is the easier way to do it. We do a for loop, like I showed you before, and we loop down from that number until we hit 1. And then we do 5, 4, 3, 2, 1, right? We console log that number inside of the for loop. So whenever we call a function, oh, this is out of order, my bad. Weird. Oh, that was, pay no attention to what I was just talking about. So anyways, back to what we were talking about with first. My bad. I did say I customized the slides, so I guess I messed up again. So anyways, so function first, function second. So now we have first goes onto the call stack. We have I am first up here, and then we say second goes onto the call stack. Because if you look at first, we console.log I am first, and then we run second. So now second goes onto the call stack. And I am second happens because I am second is called. First is paused while second ran, okay? But then second gets, since it's done, we console.logged it, second is taken off of the call stack, okay? Then first is finished as running, and then first gets taken off of the call stack. Does this make sense? Okay, cool. So back to the countdown thing. So let's refactor our countdown thing, our function, into using recursion. So if we count down num, we console.log num, and we just call countdown a bunch of times, we don't use any loops, right? However, why would we ever want to do this? Why would we want to manually call countdown 5 times with a number less than itself? Why can't we just tell countdown to do that itself by changing the inputs? Every time we call countdown, we subtracted 1 from the previous number. Instead of manually calling countdown over and over, why not have countdown call itself? Right? So if we do countdown num minus 1, and we call countdown 5, we have 5, we have 4, we have 3. This is working, right? We have 2, we have 1, we have 0, we have -1, we have -2, and so on. Infinity. This is how you can really get into trouble with recursion. There is no point in whenever that we are telling this to stop. So we get our range error, maximum call stack size exceeded. Any questions on this, why this is happening? Does everybody understand why this is happening? It makes sense, right? You're calling the function itself, but when should it ever stop? We run it, okay, run it again, okay, run it again, okay, run it again, okay, run it again, right? So we have to tell it when to stop. Because our function was instructed to call itself every time, the function ends up calling itself forever until our computer runs out of memory. So let's write a stop condition so the function eventually stops. If num is less than 1, console.log done. else console.log num, and then count down num minus 1. Okay? So now, 3 goes on, we get 3. 2 goes on, we get 2. 1 goes on, we get 1. Countdown of 0 does go on, and we get done. And then 0 gets taken off, 1 gets taken off, and then 2 gets taken off, and then 3 gets taken off. And we have the same result. Does this make sense?
Could you have done like a countdown num minus 1 if greater than 1 break or something?
No, break. The break keyword is specific for loops, right? There is no loop here, right? Like, we're just calling this function over and over again, right? Try and put the break keyword in your function that isn't in a loop.
Why break doesn't work for objects?
What? What do you mean?
Well, if you're trying to do, for example, from E in some object, and then you just do break.
Wait, I don't understand why you're talking about objects, though. You know?
If you want to do the loop,
Yeah, if you're looping and you're inside of like whatever, you can do break at any point, and then the loop will stop.
But this isn't a loop.
Yeah, but this isn't looping, right? So like the break keyword can only go inside of a loop, just also continue, right? So like, if you think about it, when we're calling the function over and over again, you could think of the break keyword in this situation to be the return keyword, right? We're not using that here because at the end it just stops anyway, right? So like to break out of this, you have to return at one point, but you cannot just put the break keyword wherever. Okay. Whoops. So 2 takeaways from this countdown is that you need to define a base case. That is very important and the only way that you can break out of recursion. And your recursive case must change the input to the function so that you will eventually trigger that base case, right? So every time we passed in num minus 1, right? Right?
Yes.
Okay. Returning from recursive calls. So recursion becomes more complicated, and it really does when we have to return things from them, okay? So good practice is to start by defining a base case, and the base case often occur when there is a simple input that expects a simple output, okay? So test that base case works before working with the recursive case, okay? So the factorial problem that I just showed you, right? So define a function factorial that takes a number and returns the factorial of that number. So I don't care if you know what factorials are or not, but I'm just going to tell you what they are, right? 0 factorial is 1, 1 factorial is 1, 2 factorial is 2 times 1, 6 factorial is 3 times 2 times 1, 4 times 3 times 2 times 1, and so on and so forth, right? Every number times itself down every whole number, okay? So what looks like a simple input-output that we can use to build our base case, right? The 1. If num is equal to 0 or equal to 1, we return 1, okay? So factorial of 0 and factorial of 1 will give us 1, okay? This is how we should start. So the base case is set, and we just need to remember that our recursive case has to bring our number closer and closer to 1 or 0, so we eventually hit our base case, right? And notice an interesting pattern. So recursive case, num, must get closer to 0 or 1. So it's best to write your recursive case using the simplest possible input that will result in a recursive call. So we say let result equal factorial of 2, console.log result. So right now it's undefined because we're not returning anything, right? Factorial of 2, there is no recursive call and there is no return statement because 2 is not equal to 0 or 1, so we never hit that 1, right? So let's change it so that we do console.log factorial of num minus 1, right? So we get 1, but then result is also undefined. Okay? This is kind of annoying. So if we console.log num times factorial of num minus 1, then we do get that 2, right? Because before, we just console.log factorial of num minus 1. And what is factorial of num minus 1? Factorial of num minus 1 is factorial of 1, right? And factorial of 1 returns 1, right? So when we console.log factorial of num minus 1, we get that 1. But over here, we do factorial of num minus 1 times num. So that's 2 times factorial of 1. So that's why we get that 2 in the console. But result is still undefined. It's because our function isn't returning anything, okay? So what if we just say let result equal to num times factorial of num minus 1, and we return the result. Now result is 2, okay? So let's run through this with 5, okay? Factorial of 5 goes onto the call stack. The return value of factorial of 5 is 5 times factorial of 4. Does everybody agree with me, right? Because we throw in 5, we don't hit our base case because 5 is not 0 or 1. So we say result is now going to be equal to 5 times factorial of num minus 1, and then we return result. So that is the return value. But since the return value includes a function call, we then have to call factorial of 4. And the return value of factorial of 4 is 4 times factorial of 3. Because factorial of 4 is not equal to 0 or 1, so we go down here and we return num times factorial of 4 minus 1, factorial of 3. So factorial of 3 gets called onto the call stack, right? And we repeat this process, right? We repeat this process again, and then we say factorial of 1, right? Factorial of 1, we finally hit that, and factorial of 1 hits our base case, and we return 1. Does that make sense? We finally, all this time, factorial of 5, 4, 3, 2, they're all in pause, okay? They're not running right now, because we have to see what factorial of 1 is returning. Factorial of 1 returns 1, so that means, you see, factorial of 2 returns 2 times factorial of 1. What is factorial of 1? Actually, it is 1, right? So factorial of 2 returns 2 times 1, so it returns 2. So that means factorial of 3 that was waiting for factorial of 2 to return something, factorial of 3 then returns 3 times 2. So factorial of 3 returns 6. Factorial of 4 was waiting for factorial of 3 to return something because it's trying to multiply that by 4. So 4 times 6, you get 24. Factorial of 5 was waiting for factorial of 4 to return something, so we can multiply that with 5, right? So factorial of 4, you see there, returns 24. So 5 times 24, you get 120, okay? So factorial of 5 returns 120, and that's what we get in the console. Does that make sense? Yeah? Yeah.
On the other example, the compound, we use the if-else statement, right?
Yes.
And here we just do the if, and then we just return the result. Like why? We don't need to type else.
Well, we don't need to type else.
But is it like if it's there or?
Well, it's like, in this situation, right? In this situation, in this function, we run through that if. If that statement is true, we return something, right? If we return something inside of that if, then the function stops. So it's kind of is like an if-else statement, whereas everything else in here would be in its else. But since the if is running, the else doesn't run, right? Because the return statement cuts it off. Before, we weren't returning anything, right? So if this isn't true, we will go down here, and down here, we are returning something. So that function stops at one point or the other. Does that make sense? So like before, like we had if this, just console log this, and skip the else, where we call our function.
Yeah.
However, here, we have to return. We have to get a value, right? So we have to always call this because we have to set this value to something and return that value from the actual function at the end, right? So this here, we have to call every single time because we need to get a value from the depths from factorial of 1. We need that base case value. We need that 1 to get thrown up and up and up and up, right? That's why we don't really need an else in this situation. Does that make a little sense? A little.
No, it doesn't.
I don't know. Any other questions? Okay. So 3 takeaways from factorial. So write your base case first. That's definitely, I think you guys should do that. And test it using simple inputs and outputs, right? Write your base case and test it using the simple possible input that results in one recursive call to that base case. That will make your life difficult. I mean, simpler. Right? So test your function against more complex inputs after you do the first 2, okay? You should try to use, I don't know why it says 3 takeaways, but there's 4 things. So you should try to use Chrome's debugger. I mean, I guess you can do this. I wouldn't. Because console logs kind of are a little tricky when you're trying to debug recursion, right? But I would still recommend console logging. Don't change the way that you have gotten comfortable with debugging things because we're dealing with recursion. I think that's bad. It makes you more uncomfortable. So you can use recursion with any data type, and if you're asked to recurse through arrays or strings, the base case often occurs when the iterable is empty or has a length of 1, right? So as you saw in our factorial problem, our base case was when the number is 1, right? Or when the number is 0 with the countdown, right? Then we're just like, we decreased that number until then, and then we said no more recursion. So you can, I'm not going to give you an example, but like you can like visually think about like, okay, if I had a loop through this string, or I had a loop through this array, what if I changed that array, I changed that string, and because when you call the recursive function, right, you have to change the input. What if it was like the input with everything sliced off except the last thing? So the string gets shorter every single time until the string has no length, until the array has no length, right? When the array has no length, then we return our base case, right? So that's a usual pattern, okay? So imagine finding the sum of numbers in an array. If sum of array of 4, if array.length is equal to 1, the sum is easy to calculate, right? It's 4. So if the base case required the iterable to have a length of 1 or 0, it must mean that the recursive case has to reduce the length of the iterable with every recursive call. If you can find your base case and you can make one recursive call to match that base case, you'll be set. And you'll find out that this is actually sort of easier than you would think, okay? Nested arrays can be approached differently, and we will talk about it tomorrow. So I cannot emphasize this enough. Start with the base case and test your case with the simplest possible input that will result in one recursive call to the base case. And you should ask yourself, what type of thing should my function return? Because the base case and recursive case should probably return the same type of thing. If you get stuck on a recursive problem, try writing it iteratively. Sometimes that does help. It doesn't help me personally, so I've never told anyone to do that. But sometimes people have told me that helps them. You know, if you can't figure out how to do it recursively, try a loop. You know, see what's actually going on. Solve the problem first, and then figure out how to like backpedal back into recursion. Okay? Go back. Any questions before you guys take 5-minute break and go into pairs and try the workshop? Any questions? Okay. Take a break. 5 minutes.